mixture, how can you know whether it's homogeneous or heterogeneous? So, to assign whether it's homogeneous or heterogeneous, you need to know what could be the definition of one homogeneous mixture and one heterogeneous mixture, right? Is it correct? You don't need to remember this guy is good or not good. You just define yourself that he's going to be a good guy. If I ask him to borrow, let's say 1 billion Vietnam dong, he will give me directly, right? If he say no, he's not a good guy, by definition, right? So later when you see any guy, you ask the same question, can you give me 1 billion Vietnam dong? If he say yes, it's good boy. No, not good boy, by definition. You don't need to remember this guy is good, this guy not good, because you cannot remember everyone, right? So now, what could be the definition of the homogeneous and heterogeneous?
Homogeneous mixture, if you look at it, it will look like the same, and you can see the difference between the CO2 or the O2. But the heterogeneous mixture, you can see something like they are different to each other in the same mixture.
Okay, thank you. So by definition, homogeneous, that means any position of the mixture will have the same chemical composition and same physical property. You cannot distinguish the border between the 2 components or 3 components in the homogeneous mixture. While for the heterogeneous mixture, you are able to distinguish at least 2 positions, 2 points, where the chemical composition and physical property are not identical. And you are able to define the border between the components in this heterogeneous mixture. For example, this one, if you take a position here, in this point, and the position here, they are not identical in terms of chemical composition, right? Here, you have oil, and here you have water. So basically the chemical composition are different. And in terms of the physical property, this guy, this point and this point, they are not similar, right? The surface tension, the surface energy will be not the same. And you are able to define the border here between this point and this point, this matter and this matter. Okay? So this kind of mixture we call heterogeneous mixture. Is it clear? And you have one principle saying that light will dissolve light, this light dissolve this light. It means that you have a polar compound, it will dissolve polar compound, non-polar compound will dissolve non-polar compound. Okay? Hydrophilic will dissolve hydrophilic, hydrophobic will dissolve hydrophobic. Okay? So if you visit this kind of bookshop, who they try to fit the motorbike, sometimes we get a problem with our motorbike, and you will see that after fixing the motorbike, the hand will be contaminated with oil, right? Is it? So you will see that they will never go to wash the hand with water, because oil is hydrophobic and water is hydrophilic. So they will not dissolve together. So if you wash hand with water, it will be not clean, because water and oil, they generate the heterogeneous mixture. Okay? So in that case, did you observe how did they do to clean their hand? Yes?
Mostly use soap, as it has a component that can mixture oil and create it become some kind of component that is hydrophilic. So water can, and by using water you can wash off that component.
Okay. This is one possibility. Normally they use. Another one.
I believe that we could use organic compounds such as benzene, pentane, or hexagon because they are organic and they could dissolve their own.
Actually, it's correct, but they will not use benzene because they don't have. They will open the gasoline. They will open your gasoline order. They pick up the gasoline from the tank and they wash. Right? Because gasoline inside is hydrophobic, it's also organic compound as we say. So it dissolves very well in the oil. Okay? Okay. So in the laboratory, when you go into any chemical lab, you should be familiar with this one. Let's say which solvent will be miscible with which solvent. Okay, you don't need to remember, but you need to understand the principle. For example, the yellow one is miscible solvent. Let's say if you take the benzene here and you mix with water, it will not miscible. That means you will have heterogeneous mixture. You will have one layer of water and one layer of benzene. But if you mix with butanol, it's okay because it's miscible. Okay? So let's say if you want to do a chemical reaction, you decide what kind of solvent you use, or what kind of mixture of solvent you use, you should be able to look at this one. It's kind of easy to read, but it's important. Okay? And another methodology to wash hands, your colleagues just mentioned, is that they use what we call the concept of micelle. So basically, this compound, you will have this kind of compound. You have here, which is hydrophobic, and this one is hydrophilic. So when you put this compound into water, all the hydrophilic heat will oriented to the water, and all the hydrophobic will orient inside. You have a kind of balloon. So now, if you use this compound to wash hands, all the oil will get encapsulated inside. And this can be dispersed in water and washed out. Okay? So that is the principle of knowing detergent. And you remember, maybe you don't know, but I would like to share with you that all the products from the Unilever of Vietnam has been founded by this Vietnamese chemist, Louis Potendam. Okay? So when the Unilever decide to come to Vietnam for the production, they invite Louis to come back to Vietnam to make the formulation of all the products you are using today. Why they need to adapt? Because the moment they come to Vietnam is early 1990. And you remember that in 1990, you don't remember because you were born in 2004. But you know, you can imagine that in 1990, in Vietnam, people wash doing the laundry by this way. All the clothes they do like this. During chip chatting, they do like this. And what the problem? The problem is that if you wash by this, it will be different compared with washing by machine. Because washing with machine, you can control the temperature. But washing like this, the temperature will depend on the temperature of ambient. Let's say in the winter time, in the summer time, the temperature will be different, about 20 degrees or 15. Okay? So this scientist need to apply all of this knowledge in the chemistry of detergent to formulate an adaptable component for the Vietnamese people at that time. Because normally you can put quite like an oxidative compound to destroy or to cast the oil, right, or dirty. But if you put too much oxidative compound, the hand will be affected as well. So then he need to balance one of them. So I got time to talk with him in 2005 in Lyon, in France. So he tell me all of the story he worked in Vietnam. And his book, Formulation of Detergent and Personal Care Product, is excellent book. And the book, scientific book, technical book of this field. And basically, if you are working in the field of personal care formulation or detergent formulation, this book is like the book you need to have in your at home and in your work. In our department, we have one copy of this one as well. Now, warm up a little bit with funny science. At funny science, you can have a question like you have a mixture of salt, sand, and iodine, solid mixture, heterogeneous mixture. Please get a strategy to separate the three components. Okay? The second question is please get a strategy to purify iodine to get pure iodine. Can you work on this in 2 minutes? How can you separate the three components? Một hỗn hợp cát, muối và iốt. Biết đồng nào mới tạo ra cái hỗn hợp này mới sợ chứ, đúng không? Còn thôi, em quên nó tạo ra rồi, thì làm nào để tách nó ra thành cái một. Yes?
Okay, so in my opinion, first of all, I will burn this mixture in fire so I can receive the iodine, and then in the mixture is have a sodium chloride and the sand, so I will put it into water and mix it so I can get the sodium chloride as the liquid. And then if you want to make the sodium chloride as the solid, so burn the liquid of sodium chloride, so you can receive the
Okay, that's the answer. Okay, thank you for the first question. The second question. Thank you, excellent. Second question, how you can get the pure iodine? Huh? Basically, he gave the answer already, right? You heat up. So when you heat up, the iodine will become the vapor, right? Because of sublimation. So we collect the vapor, cool it down, so it becomes pure iodine. Okay? So that's the funny one. In real life, a cup of coffee like this, when you have a lot of chemical components inside, and they even figure out that in the same espresso cup of espresso, the chemical component depend on variate in function of the from one bar to another bar. Even if you have the same machine, that the way you do the espresso can provide different chemical components, because the attraction from the component from the coffee powder will be different, depend on the temperature, depend on the pressure you have, depend on the time the hot liquid will go through. Now, more serious. Okay. Air in Hanoi seems to be polluted. Okay. We experiment it every day when we back home, right? So, question is, how can it be purified to provide fresh air to the people? Anyone can have an idea? So think about that at home, okay? I have to say that I don't have an answer. And also in the air of Hanoi, you have what you call particle with a size of 2.5 micrometer. We call the PM 2.5, right? And inside the PM 2.5, you have a lot of aromatic hydrocarbons like this one. And all of the chemicals are cancerous. So for the moment, there is one question, big question, whether the particle itself are dangerous. Maybe the biologists can answer. Or the particle itself are not dangerous, toxic, but the chemical component penetrated inside the particle become, when they release to the human body, it becomes toxic. So that's something what we call, in our field, we call nanotoxicology. That means the toxicity of the nanomaterial, nanoparticle is something new. So if you, some of you are interested in this field, you would have a lot of chance to work and contribute in this field. Another question about the nature. What do you think? People in Hanoi try to get higher level because actually the housing price at the higher level in the high building is much more expensive compared with the lower level. Is it correct? You get higher price. And some of my colleagues say that, some of my friends say that it's expensive because when you get higher, the air becomes cleaner. So the question is, thank you. So the question is that whether the concentration of the particle, the polluted particle, increase when you get higher level or decrease. So it seems that you got the answer, right? Now, a big question. I would like to invite you guys, come from ICT, data science, from environmental science, from climatology, chemistry. The question, the concern of Hanoi is following. Is it possible that you generate a kind of pollution map of Hanoi to see in which position the pollution is higher than which other one? And can you predict the evolution of this pollution in function of time, in function of raining, in function of war, in function of the farmer in Dong Nang who burned the chore? And, ladies and gentlemen, another thing. Not far from here to the northern border of Vietnam with China, what could be the distance? 300, 400 kilometers, right? And in that side, they have nuclear power plant. Okay? So now the question is that, in the case of disaster come from nuclear power plant from China, in which situation, in which scenario, Hanoi will be affected? In which season, Hanoi will be safe? Because we don't know at which moment the accident will come, right? So we need to prepare all of the scenario. If the accident happened in the October, the behavior of Hanoi can be different compared with happened in the summertime. You understand what I mean? So all of that, all the chemists cannot solve, all the environmental science cannot solve. It's a big picture, a big question. So if you are interested in this kind of big question, to work together, to think big, not 20 over 20 of the general chemistry classes for nothing, this kind of question, I would like to invite you guys to think about and to move on. Because that will be something extremely important now in Hanoi and in the 10 years to come. Because you cannot imagine that you increase GDP per capita, you increase the salary, but at the same time you need to prepare for the healthcare as well, right? If you get double salary, but you pay double in the hospital, is for nothing. You get what I mean? Okay. Another funny thing is that if you take tree suspension, if you take water, you take a laser point, you put the laser point in the water, you see that the laser point will go through the water, right? But if you put in this kind of suspension, you will see the scattering of the laser. So that comes from one idea which is important for the environment science, that's how people can determine the size of a particle, right? So let's say, you imagine that if a particle like this, you send a beam, so smaller one, the scattering will be bigger. The bigger one, the scattering will be smaller. So based on the scattering, you can define the size of particle. So that's also the thing that you can develop further. Okay, not need. So now we talk about element. Element is smallest substance, contain only one kind of atom, cannot be decomposed into a similar substance, right? That we call element. So you have silicon, which is very abundant, 28% on our Earth crust. And the silicon is actually important for all the energy conversion here, devices, for example, solar cell and so on. And you understand why they call Silicon Valley, right? The Silicon Valley because of the first industry evolution based on the transistor diode and transistor diode based on silicon. So you can see that you have 28% of silicon, and the silicon is extremely important. But ladies and gentlemen, again, s'il vous plaît, again, the problem is that in Vietnam we don't know how to produce silicon. So Vietnam is the second largest, second biggest producer of silicon solar cell. So solar panel, right? If any one of you are living in Bắc Giang, you get in any industry Bắc Giang, you will see the silicon solar cell company. And they produce silicon solar cell to be exported to the US, to Europe. So Vietnam is the second biggest producer of silicon solar cell. But we don't have the technology to do the purification of silicon from the cell. Okay? So all the silicon we need to import from China. So we have a production of silicon solar cell, but all the starting material we import from China. So you see how it's not good, right? So now the question is that how you can take silicon Se from silica SiO2. A simple question, right? You learned already at high school. Okay? So if you play with the question, a picture like salt, sand, sauce, iodine, you can get 20/20, but you cannot earn money. Okay? But if you try to think about the question, how you get silicon from silica, you don't need 20/20 because you have 20 billion US dollar. Okay? So next, the camber. The camber by definition is substance composed of two or more elements, or two or more kind of elements. Can be decomposed by chemical means into similar substance or weigh in the same ratio of mass. Let's say water H2O through the electrolysis always produce hydrogen and oxygen with the ratio 2/1. Okay? So please read the definition before we go to the question. Camber. A substance composed of two or more elements, two or more kind of elements, that's by definition. This can be decomposed by chemical means into similar substance or weigh in the same ratio of mass. For example, water always will produce through the electrolysis, it will produce hydrogen and oxygen with ratio 2/1. Is it clear, the definition? Yes? Very easy, right? Now, please solve this question. Let's consider following species. You have three, FeO, FeO 1.02, Fe2O3, and Fe3O4. Which of following statement E or R correct? First, the two components are actually identical. The two components are two different, they are not identical. Iron 3O4 have both chemical character of iron O and iron 2O3, and these sum of iron in within the second compound have similar chemical character to the iron atom within the iron 2O3. Now it's more chemical, right? More chemistry. So please pay 2 minutes to solve this question, please. Okay, I heard from your friends say that the component, the second one, iron O1.02, will not happen in real life, right?
Yes.
But actually, this happens a lot, and iron, the first component, iron oxide, is rarely happen. The second one is the more popular one, the very popular one. Okay? So you see that the chemistry absolutely learn and the real life have a gap. So the proposal that I invite you guys to reconsider, that open and reconsider the chemistry by another way. Okay, so let's work together. The first one, correct or not?
No.
No. How they are different?
So by definition, if you decompose the FL and the FL 1.02, it will not have the same ratio of mass.
Okay. So they are not similar, right?
Right.
So they are not similar because the identical should be the one who have identical chemical composition, and when you decompose, you will have the same product. So here, the first one, when you decompose it by chemical means, you will have iron and oxygen ratio 1/1. The second one, you have a ratio 1/1.202. Okay. So the B will be
Incorrect.
correct or
No.
not correct?
No, not correct.
There are two different compounds. So A is not correct, right?
Yes.
The A is not correct because they are not identical. So the B is correct or not?
No.
But they are not identical, they are not different. So what I mean?
They have the same compound. They have iron and oxygen.
Huh? A is not correct, right? A is wrong.
Yeah.
Okay? So they are not identical. So now B is correct or not? They are different or similar.
Similar. Different.
But actually they are different compounds. So the B is correct. Okay? So C, Fe3O4 have both chemical character of the first one and the first one. Is it correct or not?
Yes.
Yes, that you learned already, right?
Yes.
And the first one, some iron atom is the iron O102 have similar chemical character to the iron atom within this iron 2O3. Is it correct or not correct?
No.
So to answer yes or no, what could be the oxidation state of iron 2O3? 3, right? Is it correct? So the iron here should be iron 3, right?
Yeah.
And normally the iron in this compound, FeO, will be iron 2, right? But how can it make you have more oxygen than 1? Because if iron is 2, oxygen 2 minus, so the ratio would be 1:1. So how this compound can make to have more oxygen? Let's say where 002 oxygen come from and where it can put in this structure. Do you get what I mean? Huh?
So that the ratio between the iron and the oxygen will not be like 1:1. It will be, some of them is the iron 2 and some of them is iron 3. So we achieve the echo, iron and oxygen, oxidized 1.02, I guess.
Okay? So thank you. So the solution is that sum of iron should have higher oxidation state, which is iron 3, to balancing the negative and positive charge. Okay? So that's why in iron oxygen 102, you have some iron 3 plus 3 oxidation state. So it means that it have similar chemical character to the iron in the iron 3. Okay? So the D is correct. But now it's curious for me. Imagine that this one is oxygen, right? The rest one is oxygen. And the brown one is iron. If all of the iron are 2 and all of the oxygen are 2, so we have a perfect balance. Okay? So the ratio will be iron oxygen 1:1. Okay? And you mentioned the sum of oxygen, iron here will be oxidized to become 3. So that means you need to invite some oxygen come to the structure, right? So if you look at this structure, where oxygen can be put in?
I think that it would not retain that structure when more oxygen comes.
Huh? But as I say, this kind of thing, iron oxygen 1.0, is happened a lot. So what is the problem? You understand my point, right? If few iron oxidize to become 3, that means the positive is extra, become excess. So the oxygen to manage, you need to invite some oxygen from somewhere. Okay, I understand? But where the excess oxygen from somewhere can put in this structure? Huh? If I say this one, it can be difficult to imagine, right? But if I say iron 0.98, oxygen 1, is it easier to understand or not? If I say excess oxygen, that means new oxygen come to the structure, you could not be able to imagine, right? But if I say that you have some deficit in iron, it's easy to understand, right? Imagine that this guy go up. This guy, iron. So you have one iron lacking, right? So if you have 3, 1, 2, 3 iron, X iron will have oxidation state 2. But now if this guy go out, you have 2, that means X of this guy become 3 plus. Okay? So actually, when I say that excess oxygen, I also say deficit of iron. Okay? Yes or no? Okay. Now we move to the last part. Energy. Energy is defined transfer heat. We know many forms of energy, including the chemical energy, light energy, electrical energy, and heat energy. Energy can be classified into two principal types: kinetic energy, so moving, and potential energy, the attitude, the heat. Okay? So, you have potential energy, you have potential energy when it falls, and you have kinetic energy representing the moving. Okay. Clear definition? Any problem?
No.
No? What is energy transformation provided by the following device? In Vietnamese, we call buồng nước or cọ nước. What the energy transformation you can see it here?
It provides oxygen for sleep.
Huh?
It will provide oxygen for the.
Provide oxygen?
Cái đấy là nó tập nước.
Các bạn biết cái này đúng không?
Biết ạ.
Thế cái này người ta dùng để làm gì? Hả? Chết dở, thế khách hàng mình So basically, we have two forms of energy, right? Potential energy and kinetic energy. It also says that between the kinetic and potential energy, you can make the transformation. Kinetic to become potential, potential become kinetic, right? Các cụ nhà mình nói trèo cao thì ngã đau. Okay? Cao mean higher potential energy. When you fall, it's faster kinetic. Okay? So it's hurt better. But now in this device, what will be the energy transformation? You can see it here. Kinetic to potential or to potential to kinetic? Huh? Kinetic to potential, right? Because the flow of water here, actually the kinetic, to make the water turn, okay? And when it turns, it brings water up there and to flow the water by this way, right? So it means you transfer from the kinetic energy to the potential energy at higher level. Is it clear? So when you have a process, you have two processes, exothermic and endothermic. Exothermic, that means the process will release heat to the environment. And endothermic is the process will absorb heat from the environment. Okay? So when you burn the gas, it's going to be exothermic. When you have a cup of beer, it's going to be endothermic. But why, when you have a cup of beer, what the process behind to make this endothermic? Why this cup of beer need to absorb energy? Huh? Because it's cold, so to become okay. So the first is that's the thermal equilibrium, right? It will reach the equilibrium temperature between the cold and hot environment. The first thing. The second thing that you know inside here you have dissolved CO2. So when CO2 release, it needs to absorb energy. Okay? Now, the next one is better. Huh? You know this, right? You know this person, right? Phạm Tuyên. Do you know Phạm Tuyên?
No. Yeah.
Okay, if you don't know Phạm Tuyên, this is in the slide already. This self-study, okay? This one is okay. I provide already, no problem. Okay. Now, we move to the last slide and we stop. We have the law of conservation of matter. There is no observable change in the quantity of matter during the chemical reaction or during the physical change. That means the matter will be not created, will be not disappear, it's changed from this matter to another one, is formed to another form. Okay, that we call the law of conservation of matter. You have the law of conservation of energy. Energy cannot be created, cannot be disappear, it's only transformed from this form to another form. So when you say that we need to produce new renewable energy, you talk wrongly already. Because you cannot produce renewable energy. You use from somewhere, you convert into the energy you use. That's all. Okay? The combined amount of matter and energy in the universal is fixed also. Okay? So we talk about the law of energy conservation. Okay? The energy cannot be disappear, cannot be generated, but only transformed from this form to another form. Okay? Clear or not?
Clear.
So the last is here. We in Vietnam, we produce a lot of what we call the solar panel, silicon solar cell. That is a device that absorbs the photon energy and create the electron and hole. So the hole will go by this way, electron go by this way to create electricity. So basically, you make the transformation with this device, you make transformation from the photon energy into electricity. Okay? So the photon energy, sunlight is abundant and renewable. Today you don't have sun energy anymore, we don't need to care because we die already. Okay? So the sunlight is something abundant, renewable, we can expect. Now, the problem. Here you have a farmer of thousand species of silicon solar cell. Okay? They link one to each other to produce the electricity for the whole country or the whole city. Okay? Now, the question is that how can we identify the broken solar cell among this team? How do we know that, oh my god, this guy already broken down, we need to change? You understand my question? Or we will make, okay, can we come to make measurement? Okay, it's good, it's good, it's good, it's good. Okay? How can we make this kind of identification? I have to tell you. Nowadays, this is a big problem in any farmer of solar cell in Vietnam and over the world. Okay? In Vietnam, we have some solar farmers like this, and this problem, how to identify the broken one, is a big technical challenge. So how can we make it? Yes?
Okay, so first of all, we will. I think this is very tired for people who is the farmer of this solar because we have to go and see of 1,000 of this. If there are any of the panel is changing the color or the mica of the outside is cracked.
Okay, if it's cracked, I can see quickly, then no problem, right? If it's cracked, it's easy. But if it doesn't crack, it's still perfect, but it happens inside, it doesn't work correctly. So how can we do?
We use the
Yes?
voltmeter.
The voltmeter.
Yeah, the voltmeter.
But you have 1,000 like this, how you can come to measure the voltmeter one by one?
Yeah, I think it's yeah.
Ooh,
Okay.
okay. Thank you. But we take another solution. Yes.
And measure the kind of the electricity that is produced in these cells. If there are, it is broken inside, that we should know that the kind of electricity it produces.
But how the all of these devices, they link each other, right?
Yeah.
The output performance will be the output performance of the whole.
Yeah.
So if one doesn't work, will not work. You will see, right? If one doesn't work, you cannot identify. Let's say, if all of you here sitting individually, and I give you 1 kg, if one will not carry this 1 kg, I can say that you don't carry me with that. But if all of you become a unique team, and I say that you are 300 guys here, please bring for me 300 kg of object. Maybe one bring 2, another bring 0. But if I wait outside, I don't know who bring and you get what I mean. So if you apply the concept of energy conservation, what could be the idea? And when I talk with this one, I talk with one of my friends who is now working in Solar Energy Institute in Grenoble. He has one excellent solution I will solve it. So the idea starts from here. Energy conservation, that means the photo energy equal to the electricity and heat. Okay? Is it correct? And of course, you don't have 100% of energy conversion. All of these solar panels will have some heat, which is lost energy. So imagine that if the solar panel will not work anymore, you will not have electricity. But you will have all energy become heat. So you can imagine that in terms of temperature on the surface, if this one is broken down, the temperature here will be higher than the surround. Is it correct? Because you have more heat. And if you look at this one, you know how you can use the thermal camera to detect the people with the fever, right? So basically, they take the camera, and if you have only 1 degree difference, you can detect. So the thing is that our friends in Grenoble, people told us, he take a flight cam, okay, and take the camera with his screening camera to fly through the farmer. And when they see the temperature higher, they will quickly say that in this area you have a problem, you have trouble with the solar panel. So they come with a voltmeter. Okay? Last question. Beautiful, right? We have a big solar farmer in Lincoln province. And in Lincoln province, you have this kind of cell places, right? Concave, okay? It's okay. It's nice. But the problem is that during the operation of this solar panel, this cell in the world, in the atmosphere, we cover the surface of this solar panel. And you have energy conservation saying that the photo energy will equal to electricity plus heat. So if you have a layer of the powder covering the surface of silicon solar cell, the photon energy cannot reach the solar cell correctly, so you have a lower electricity, right? So, the last question is, how can we clean out daily to maintain the best performance of solar cell? Okay? So, any idea, quick idea, before we stop our lecture?
So we can make something at the bottom of the solar panel so it can rotate to the sunlight. So the sand would be pulled out by gravity.
Okay. So, your friend said that, hey guy, anyway, you need to move the solar panel to track the sunlight, right? Because our planet turn around like this, so basically the solar panel need to turn around also to catch the best performance. So, if you have the system to turn like this, it's better you make also using this turning system to wash out all the powder, right? But you can try at home. You have the fan running like this, you have a lot of powder catch inside, right? And you see that the fan run like this, but the powder still remain. Is it correct? So it means that when you turn like this, only the big powder can fall, but the very small one will remain. So, in Nepal, one engineer proposed that we will take the seawater to wash it. So we pump the seawater, so it's washed very well, clean. But tomorrow we figure out that the performance decreased. The reason is that when you wash with the seawater, inside you have sodium chloride. So when the seawater dry up, on the surface of silicone solar panel, you have one layer of sodium chloride. And sodium chloride is crystal become like a kind of pyramid like this. So it will reflect the water, the photon. So the photon reaching the solar panel decrease. The performance decrease, even it looks clean. So this is also a big problem nowadays. Ninh-Thuận farmer and other farmer in Vietnam, solar farmer in Vietnam, they need to take care. So if you have any technical solution, please think about this. Please propose. I don't have. Okay, thank you.